Hello and welcome to Apropos. We are live and on time today. I can't believe it. Uh, so this is a show about Clojure. We talk about Clojure. Usually now we're trying to have a guest, and we have a very special guest today. But before I introduce him, we're going to talk about our panel. We have Ray,
Hello.
Mia,
Hello.
I'm Eric, and our special guest is Alex Miller.
Hello.
The one and only.
Why is
Do you
Eric
want to
suddenly
tell
gone
us
into
just a little bit
whichever?
about yourself?
Okay. You are there
Am
now.
I
You're
not
there now.
there?
Yeah, no.
Oh no.
I gotcha.
Well, I
Yeah,
was just asking Alex if he could tell us about himself.
sure. I'm a Clojure programmer in that
Yay.
I program Clojure. I started with Clojure in 2010-ish, 2009, 2010-ish, and joined the core team in 2013 at Relevance, which quickly became Cognitect, and then was acquired in 2020 during the pandemic by Nubank. And I've been working at Nubank since then, and they continue to fund a team of us to work on open source Clojure stuff.
I can't believe
Can
it
I
was
tell
that
you,
long
Alex, that I
ago.
first saw you in Belgium at a conference, at a DevOps conference, I think it was, all those years ago.
I missed the conj that year. The only conj I ever missed was to go speak at Devox.
Huh.
Wow. Okay. Sorry, Mia.
Oh no, I was just gonna tell you that's that long ago. That's 5 years now. It feels like new news.
I know it's I'm an old timer there. They've hired 5,000 since I joined or something like that.
How many Clojure developers would you say are at Nubank?
This is a shockingly difficult number to ascertain. We were just talking about this the other day, but I, I've had people confidently tell me that there are at least 1,000. So I'm going with that number.
Mhm.
Probably might be closer to 1,500. There's like about 2,000 engineers, I think, at
Hmm.
Nubank. So there
Is
are a
it
lot of,
so hard to know?
it is actually. I don't know.
I guess it's a bit of a
No, like
fractal number, you know?
there's there's no one place to get that information.
Hmm.
So like,
I hope they all get paid though. Like someone has to
oh, they
know
get paid.
that. Okay.
They get paid. I
Maybe
mean,
people's designations aren't always perfectly clear, though.
no, they just have like, they're just like a senior engineer or whatever. So you
Hmm.
don't
Yeah.
Ah,
lots of
right.
stuff. So there's no like closure. There's no what language are you doing today designation.
Yeah.
Right. Well, that makes sense.
Yeah.
So we have the questions, uh, and we are going to start with what is your editor of choice?
I use IntelliJ. I've been using IntelliJ and Cursive for a long time. So I have spent
Excellent choice.
significant periods of time using Emacs and using Calva, and in the olden days using Eclipse and using NetBeans. So I've done different things over different periods of time.
What are your must-have plugins for IntelliJ?
The only things that I have are Cursive and um, I have there are dozens of ASM plugins, ASM, the Clojure or the JVM bytecode library.
Mm.
There's one that I found that actually does something useful, which allows you to basically select a class file and see the bytecode for it in IntelliJ. And
Oh,
I actually used to use that a lot. These days I use the Clojure Java decompiler
Hmm. Hmm.
from Clojure
Oh,
Fast instead, which
so
is
now there's no more useful ASM plugins. There was one, but
I, that one actually does work or did work the last time I used it. There are
what's
most
it called?
they
Just
are
the
all called basically the same thing.
oh, so you have
Some
to try them all until you find the one that works.
I can tell you the one that actually works. Let me see. I'll look at
Mhm.
that might be useful now.
This
Oh,
you're using
ASM
the oh,
bytecode viewer is the one that I use.
the Clojure disassembler, does it just print it out to the REPL?
Yeah. And I actually use both the disassembler and the decompiler
Mm.
for different purposes. A lot of quick stuff is easier to parse using the decompiler, but I also have read enough bytecode that I also use the disassembler fairly regularly as well.
So can you give us like a scenario of when you would use that? I don't know if I've ever needed to look at the bytecode. And so it's hard for me to imagine when I would do it.
Yeah, anytime. Well, I mean, I'm doing it sometimes. I used it a lot last year when I was working on the functional interface coercion stuff.
Mm.
It's emitting dynamic, invoke dynamic stuff, which is like insanely annoying bytecode to read
Hmm.
and understand.
Hmm.
It would tell you like it would lace all those pieces together. So that's useful. But I use it for things like perf tuning. So if I think I know what it's doing, I probably have a better mental model of it than most people, but I'm regularly surprised still about what's actually happening under the hood. And so occasionally I use that to make sure that it's actually doing what I think it's doing. And the decompiler, the problem, the reason I use one or the other is the decompiler is emitting Java code, but it's not, there is no Java code. The Clojure compiler doesn't create Java code and then compile the Java code. It creates bytecode directly. And then the decompiler decompiles it back to Java.
Huh.
There are things you can say in the bytecode that have no equivalent representation in Java.
Right. So what does
So
it do in that case?
it tries to figure it out, but I mean, there's some cases where it doesn't, it can't figure that out. And
Uh-huh.
it'll even notate it sometimes and tell you that. But like
Okay.
things like local clearing, that doesn't, that's not a thing in Java. It's a thing in the bytecode.
So does
So
it turn into an assignment or something? Or
you'll see it nulling, it kind of puts things into the code that actually you would never have in Java code.
Mhm.
Um, so I worked on a locals clearing problem last year, so I looked at the bytecode a lot to make sure it was doing what I thought it was doing, but
Mhm.
stuff like that. So
Got it. Yeah, I guess if you're working on a compiler, you got to see what it compiles to.
yeah.
So you're, and this is not on the questionnaire, but just thinking about, you're kind of one of the guys that are steering the ship. Uh, and so when you're thinking about priorities for closure, what are your priorities for the short term for where closure is going?
So like the meta priority is always trying to solve people's problems, right? So it's always like, what are we seeing is like the big things that people are having trouble with? And there's lots of little things like, there's lots of that there's hundreds of issues out there and all of them are something that some person ran into. But trying to look at the bigger problems of like, I mean, there's big themes, right? Like how can we better leverage the host? So like a lot of the things we did in 112 were
Mm.
let's catch up to all the improvements that have been made in Java, the language, and in terms of functional interfaces and other streams and other stuff like that. And like how can we make those things more accessible to Clojure programmers? And there's other things like that still to do. Or how do we leverage host capabilities like virtual threads, which is a thing we're, thinking about a lot these days.
Oh,
Mm. Mm.
Stuff like that. So, or like, am I seeing a lot of code where people are like, I actually read a lot of people's Advent of Code solutions.
Mm.
Um, I've never gotten around to doing any of them myself, but I do find it useful to like skim 10 people's answers to the enclosure to one of them because I will frequently see things that immediately like, oh, this is dumb that all these people are doing this thing. So like we made those parse functions a couple releases ago, the parse long and stuff like that, because that was in everybody's Advent of Code thing. Everybody did it slightly differently. Nobody was accounting for primitives, right? Pretty much.
Mm.
So like that was a case. The Clojure math stuff, same thing. Those things showed up in Advent of Code all the time. It's one of those places where the stuff exists in the host, but if you're new to Clojure, you don't know it's there, and so you don't know to reach for it. And if you do, you probably don't do it the best way because there's a lot of tricky little details about it. And so stuff like that.
That's a great way to figure out, yeah, what the kind of heuristics everyone's converging upon that haven't been implemented yet. How long have you been doing that?
I don't know, long time.
All right, so there we go. If you do admin of code and Clojure, Alex Miller he's judging your code.
I'm not
Uh,
judging patterns, so I understand. I know what
That's
people.
That means
cool.
you're doing God's work because you're
Yeah,
contributing to the pile of priorities.
yeah, that's cool. That's a cool way to do that.
Yeah,
All right.
we meet and make a spreadsheet of like, here's a bunch of ideas that we could work on. What do we think is important right now to either the community or, or that we think is interesting to work on, or it could be a high leverage thing, or, we've got more of those ideas than we will ever have time to work on. So it's just figuring out what we're going to work on, this year or whatever.
Hmm.
All
Um,
right.
can I ask one more question? I know one thing we did a few shows on 1.12, I think. Um, and one thing that I think came up several times was what about Varargs? And I know that it's complicated, and I'm just curious, is there a way we can follow along with the design process for that? Is there a way to see like what are all the options that are being looked at
I
and
don't have any way for you to do that at the moment. I mean, it's not a thing that I have in hand right now, but like I personally have spent probably more time on it than anybody else.
mm,
Um, we have a lot of sheets and a lot of ideas. It's actually so I've sort of narrowed the scope of what is important a lot. Um, it's interesting in that like what you sort of conceptually want is that you've got this invocation path, some invocation expression that's got some number of arguments, and you
hmm
want to call some Java method that might be a varargs or might not, um, and match those up appropriately, right? And the problem, there's so many little nuances because Java allows you to overload, fixed and multi-arity. So you can have like a one arity and a two arity and a n arity or a two plus n arity. Or I don't remember exactly what's allowed, but there's some
yeah.
things there where it could potentially match what you have could potentially match multiple Java arities. And then do you like which one do you intend to call? And then we have the other complexity that we for a long time have supported just the sort of underlying JVM arity, which is varargs as a last arg, which is an array, right?
Hmm.
So so you can cut it up into three cases. The cases are I have 0 varargs, 1 vararg, or n varargs, right? Or I guess the one has a subcase, which is I have an array, right? So like
Mm.
the many ones, if I'm trying to call a method and I've got more args than I need, and it's a vararg method, then it's pretty clear what you should do in that case, right? And if you are trying to call a method that takes one fewer or like one, like the 0 case is actually pretty easy to detect. The 1 case is the tricky one because you could have the actual arg you're passing or an array. Um,
Right.
Mm.
it's
Is there a way to know in the Java, in the reflection that it is a varargs?
Yeah, there's a flag for that.
The flag. Okay.
So it's marked that way.
Uh-huh.
But even so, it could be a varargs method that takes arrays.
That's right. Yeah.
There are just knowing that you have an array in hand actually doesn't solve the problem.
Right.
We do have this new syntax that we added in 112, which is the arg, whatever they're called, arg.
The type selector thing.
Yeah, what the heck is it called?
Yeah.
Like a,
It's like a type tag or
type arg types.
arg
Whatever it's
types.
called.
Yeah.
I'm blanking on what it's called now. Param param tags. Param tags. Param tags.
And tags. Yeah.
Um, or maybe we changed it to argtags. Okay, we did both at one point. Now I can't remember which one. So if you do that, then you have a way to state your intention of which method you're calling with a precise signature. That again resolves the zero in the many case unambiguously. It does not resolve the one case, but maybe we could make a rule about that, you know. So it's just one of those things where it's tricky.
Sure.
If you're going to pass multiple things, do you pass them loose? Do you put them in a vector? Do you currently pass them in an array? Like ideally what you'd want is to pass them loose, but like you can't actually do that necessarily.
Do you have to support I mean, I think I know the answer, but do you have to support the old case of passing in an array of arguments?
Yeah.
Hmm.
Everything would break if you didn't do
Yeah.
that. Clojure itself would break if you didn't do that.
Mm-hmm.
So yeah, that would be bad. So when I look at it a lot more though, the case that's the most important one is actually the zero case. Like the place where it's really annoying is I'm calling a method that takes vargs and I don't have any.
Right.
And
And
you
I have
have
to
to
make an
go
array.
the array.
At least you don't have to do the string name of the array anymore,
No,
like type of the array anymore.
that's better usually. But yeah, it's so I think like maybe it's a matter of solving a smaller problem. Maybe if we only solved that problem, it would be better. I don't know. We haven't picked it back up again, but it's yeah. So or you could
What
add some
is
syntax.
param tags?
Param tags gets you a lot closer to being able to. We have a new way to state our intent that we didn't have before.
I'm saying that is I looked it up. It is called param tags.
Oh, okay.
For the people watching at home.
My senior brain.
All right. Varargs. So what is your Clojure story? This is I don't know this. What's your Clojure story? How did Clojure find you?
Talked about it a bunch of times, but I knew Stu sort of before from way back because we were both on the No Fluff Just Stuff speaking circuit. So I'd met him a few times. I read his book and knew him a little bit through various channels. And so I was watching his Java.next blog series back then, where he talked about Clojure. I was like, oh, this is cool. I did some scheme in college. I was a structure and interpretation of computer programs. That was my first intro class at University of Illinois, and
Oh, wow.
did scheme on Next machines and stuff like that back then. So, and it broke my brain. I already knew how to write Turbo Pascal and BASIC and a little bit of C. Like I knew some programming already, had done a lot of programming, but I was like, this is totally different than anything that I even consider programming. And I was just like, I guess I'll just take everything I know, and I guess that was all just garbage, and put it over here and like start over. But it was a very beginner mind kind of a experience for me, and it was very, very good. So, and I had messed with some other like schemes on the JVM stuff, so I was interested in it, and I was really interested in Scala too. I thought that Scala was pretty exciting, and then I got an opportunity to join a startup with some founders that I'd worked with before, and they wanted me to be the chief architect for a new product. And I said, okay, I'll do that. But I get to pick the language. And so they didn't care. They had some existing stuff on the JVM. So they're like, it just has to be you work with the JVM stuff. That's the only thing we care about. So I started hiring people and started building some like initial components that I knew we needed that were like ETL type stuff. And we started building them in both Scala and Clojure, sort of side by side. And after a few months, I was like, I kind of popped my head up and I was like, hey, is anybody still working on any of the Scala versions of this? You know, and everybody had just drifted away from them and preferred to work on the Clojure versions. And so I was like, I guess we're going to do this. I really honestly went into it thinking that we would pick Scala. And we had so many problems with the brittleness of the tools and the compiler. everything else. I mean, this is a long time ago. This is 15 years ago at this point, but
Hmm.
and we all just
Why
enjoyed the Clojure way more. So
why did you think it was gonna go Scala?
I don't remember anymore. So I've done
Yeah.
too much Clojure since then. That to seem like a good choice. But at the time, it seemed like it was. I had been doing Java. I've been doing Java since 1996 or 7, so a long time. And so it just was more similar to that. I wasn't sure that I could do what I needed to do in Clojure, but it turns out I could, and much easier. So
I think it, well, it paid off as well. I mean, if you look at like, I think they finally released Scala 3 last year, or was it last year or the year before, which is finally a kind of the proper version of the Scala compiler, this Dotty
yeah,
compiler,
yeah,
which is a type, which is a sound compiler, which is kind of weird because I remember reading that the Scala collections were Turing complete. Um, this is before Dotty, so they already had,
yeah.
the amount of complexity. I think the thing that put me off it to a large, there was two things that put me off it. One was the fact that the compilation process took so long. Now I know they've got better tools for that now, but that was a problem. And then the second thing was that it was quite a like polarized community between like the better Java people and the worse Haskell people. And it was kind of tricky to when you were when I was asking questions, it depended how good how quick people were to answer, what kind of side of the fence people led you down, so it was very
Like
confusing.
the story was, all the good parts of objects plus all the good parts of FP, and I think a lot of people thought it was like all the worst parts of both instead, or something like that, or like some mishmash of the two. I don't know. So,
Yeah, but the Scala Z
so I have
people
read a lot of
definitely, sorry, go
so
on.
reading like low level Scala is just doing like the equivalent of like, advent of code type stuff where it's not
Mm,
like doing super complex stuff. I actually really like it.
mm.
And I think from a like if you're doing like low level numerical stuff and things like that, I think it's real solid for that stuff. And I kind of enjoy reading that code a lot. Where sometimes I struggle with enclosure with all the avoiding boxing and reflection and all that stuff can be a little fiddly sometimes in Clojure.
Mm.
That's
Mm, mm.
definitely the part of Clojure that I probably am the most frustrated by at times, just because it's
The other
not.
thing that I think, Alex, I don't know if you remember this, but when one of the promises of Scala was that you would kind of like be a scripting type thing, so you wouldn't have to declare so many types. Um, so and so you're writing your code, and a lot of the kind of example code was very much like that. You could just define things, and it would kind of be inferred, and all the
Mm.
types would work out. But as soon as you started writing like proper code, you'd soon find that the compiler would complain and you had to write the types. And so all of these kind of promises, I think when people do real projects, they come across all of these situations where, you know, you can say things like we have to do all this reflection stuff, but that's only for performance. For them, it won't compile unless you actually specify the types. And that's a bigger burden, I think.
Yeah, I felt like a lot of times I was not having a I was not spending my time working on my problem. I was spending my time, getting the types
Yeah.
right and satisfying the compiler and all that kind of stuff. And like, I don't know. It's just a matter of feel. Not sure. I spent a lot of time with Groovy too. And Groovy is kind of on the other end of the scale, or like it's kind of the Ruby-ish kind of JVM language, you can kind of do all kinds of stuff and it's got all those
Yeah,
dynamic.
yeah, yeah,
It was too loose. I found that was like I didn't trust what I was doing half the time. It was good. It was great for scripting and like really fast stuff, but I
yeah.
found it to be frustrating when I wanted to actually do software engineering with it or something like that.
I
So
think one thing that might be interesting, I mean, I don't know if you can reflect on this now because obviously it's a different time, but if you were in that situation now, I think maybe people would like look at bring Kotlin into the
oh yeah,
into the kind of like
definitely.
comparisons. And Kotlin does seem a little bit more solid in the sense that it's being used by Android developers. It's definitely a better Java. It's obviously got great tooling with IntelliJ. So that might be if it was like fast forwarded to this moment in time,
Yeah.
maybe the developers might have picked Kotlin, but I guess we were
Yeah,
lucky
definitely.
that
I think it was,
Scala
I
got blew
thought
up
I was looking for
and we got you
Scala.
instead.
Yeah. I mean, the things I was looking to Scala for, I think Kotlin probably might be more comfortable for me now if I were to be making that decision. But honestly, I probably, if I were restarting from that point right now, I might just pick Java. So, I mean, Java's got
Yeah, maybe. Yeah,
better in
yeah,
some ways, and it's the easy choice.
yeah. Good call.
So, what is the last time Clojure surprised or delighted you?
Oh man, it's like it's like if you're a cobbler and somebody says, "When was the last time shoes surprised you?"
Yeah, you
Or
never you're only allowed to think about the stuff that's broken.
yeah, exactly.
Have you found something
What about the
wonderful?
light? Yeah.
Yeah.
I mean, I have not done much recreational programming in the last couple of years, but like there have been a couple of things that I did in the last 5 years where either I was writing, like when I was running Strange Loop, I used to write, well, I still have some code that I use to do um, to sort of take data feeds of CFP submissions and then build spreadsheets with ratings and stuff like that. So that I've used for selection a bunch of times.
Hmm.
Um, so I've got a pile of really garbage code that I just literally copy for each conference and then modify to my needs. But as I'm working on it, I find it to be, an easy pile to work on. And then the other thing I did a couple years ago, I was doing some stuff for a local school board election where I was the treasurer for one of the candidates, and I for a while was real into this group that was supporting candidates in the local school board election, and so I got the data file, the voter data file, and did a bunch of data analysis with it to come up with a list of names to do targeted outreach, and
Oh,
things, stuff like
that's
that. But
that's
I was
important.
just using Clojure as a data tool, really just munging around with stuff, and it was, great for that.
Yeah.
Um, so I'm gonna kind of re-ask that question.
Sure.
In your Clojure Conj talk, the last one, you seemed surprised by the high percentage of usage of Babashka.
Well, yeah.
Okay. So that's a surprise.
Yeah, I guess that's a
Mhm.
surprise.
Um, I'm surprised as well by how fast that took off and how much people are using it.
I will say when I went back and looked at the data again, my one caveat is that 40% of the people didn't answer that question. So saying that
Oh,
95% of the people were using Babashka leaves out the 40% of people who weren't answering the question at all. So it's
I
maybe not
see.
quite as high as it seemed when I first saw that number,
Yeah.
but yeah. So but you can interpret it as most of the people who are using an alternative dialect are using Babashka. And also a lot of people are using other dialects, but
Uh-huh.
it wasn't quite as high as I thought.
Right. It's not 99% of Clojure programs.
No, probably more like 50 or 60%, which is
Okay.
still a lot. So
Yeah.
Yeah, it's a
Yeah.
hell of a lot. Yeah.
a lot of people using it.
That's funny. Yeah, I hadn't thought like I think you read something like that and you just assume that like everyone answered the question.
Yeah,
Mhm.
that was
Is
definitely.
it getting to the point, Alex, maybe is in terms of like, because I know that I think I'm getting this slightly wrong maybe, but there is a sort of the whole point about Babashka is it compiles using the Graal VM, this small closure interpreter, and that's why it runs fast, isn't it? Because it essentially compiles using this Graal VM. And I know does the Graal VM itself like interest the team, or is it sort of
I
like
think I'm not
just
an
a
expert
side
on,
issue?
but I think it's two things there that like there's both. compiling to native with Graal,
Mm.
that's one thing, and then Babashka is I think is interpreting, isn't it? So it's
Yeah.
fast
It
start.
it interprets it, but it's compiled using Growl, as
Right.
far as I know.
So yeah, I think it's so there are just different approaches. I mean, I would expect, Babashka stuff to start really fast, but then to be, you know, slower if you're doing some big hairy number crunching thing or
Yeah,
whatever.
I think that's Mikhail's
Yeah.
kind of heuristic is that if you've got more than, I don't know, 50 lines of closure, it might be slower because
I
of this
hear
interpreting thing.
no,
Whatever, I don't know what the number is, but it's something like that.
I mean, it can be a little fiddly to get Graal to do the thing you want it to do, right? It might require some
It
little
is, yeah, yeah.
here and there to make sure you get everything compiled right. Um, so it is, I think, in some ways a little more complex to work with.
Mm.
There are some really interesting things going on in the JVM world in the latest JVMs, the Project Layton stuff, which is Layton is like the lightning in a bottle. So it's all this like quick start stuff for the JVM.
Ah,
Oh.
okay.
There's a bunch of
Like
different,
crack and stuff like that.
what's that?
Like this project crack. Is it Java,
That's
the
a
crack
different thing
thing?
altogether, but that's a totally separate effort. Also
Yeah,
interesting,
yeah, yeah.
but yeah, that's a totally separate thing. So Layden, and they could go together potentially, but
Right.
so Layden has a bunch of things in it. They're doing some things specifically to just increase startup time by like doing less stuff at startup. And so a lot of it is sort of figuring out what they can move, to an earlier phase or reuse from the last time you ran or things like that. And so
Oh.
they've got new tools that allow you to basically run your app for a while. And well, for a long time, we've had ways to do Java AOT that will basically capture um, all of your class files in a format that is amenable to the JVM. So like it does this processing when it pulls the class files into heap. It's, creating, JVM structures out of that stuff. And so you can actually capture all that stuff and then shove it back down to a special kind of jar file or file, and then start with that. And then it doesn't have to do all that work. It can just redo it.
Mhm.
So Layden has greatly improved that. It used to be that they could only do things that were like inside a class or a jar or something. I can't remember now. Like things that were like heap references in the heap, like they couldn't untangle them. But now if you do it all together, they can actually do a lot more of that. Um, and then the new stuff they have actually lets you run and it will capture um, things like how often you're taking all the branch prediction type stuff. It will capture, like you can give it a training run basically and say,
Uh-huh.
remember all this stuff and also remember all the native code you compiled.
Right. So that the next time you run, you don't have to do it again.
You start hot with a
Yeah.
hot shit even, with all
Wow.
stuff, with all the stat counters that you need to
Right.
prediction. And um and it can be really fast to start up. And it will run as fast as it would as if it was a hot process that's been running for a while. And it can still deopt and
Right.
fix things as it goes, just like
Mm,
it
mm.
can normally. So it
That's
doesn't have
really
any
good. Yeah.
downsides. But it has the big downside that you have to do a training run, capture a file, use it on the next time, and all that kind of stuff. So I think it's really interesting to think about, since the Clojure CLI, for example, happens to sit in that loop where you run stuff. Like,
Hmm.
what if you had the ability to do that, maybe even semi-automatically, just like remember the times that I ran this process or this same, basically command line in the past and capture a snapshot. And then, you could set it to automatically reuse my snapshot unless I say not to or something.
Right. Like you could have a flag on it that's like download a million things from Maven and then remember what it did. And so that the next time you run, it's fast.
I mean, it's doing all that. It already is doing all of that. This is like beyond that. It's like the last time I ran the JVM, I ran with some extra settings that you didn't tell me, and I captured a snapshot file. And the next time
Right.
I run the same command line, I'm going to
No,
use that.
that's what I mean. It's like there's some work, there's some heavy duty workload to warm it up, and that's long enough, and then you save all of that pre-processing stuff, um, so that the Clojure CLI would start faster the next time.
Yep. So yeah, I think it's an interesting thing.
Yeah.
I don't know if it would.
So what's kind of the way that like would you see people like building their own projects on top of it, or is it something that the Clojure team would think about like integrating some of the stuff that Project Layton is doing into Clojure? Like
I don't think there's anything that actually impacts Clojure as a language. It's really tooling related. So it's just using the latest JVM and then having it integrated into the tooling and doing, I mean, those command lines to set all that stuff up are super annoying.
yeah,
Mm.
that's
Who could do it for you?
like would Clojure CLI be able to take advantage of this?
Yeah. So I think that's an interesting thing to mess with.
Yeah, I hadn't heard that before. It's time.
It's time. Okay.
It's time.
Everybody get ready.
You gotta choose one. You gotta choose one. You gotta define it. You gotta define monad or transducer.
Oh, I'd be happy to do this. Well, monad's a burrito. We'll just get that one out of the way. So transducers. You want me to explain transducers?
Yes.
Yeah, right. Okay.
So if we look at the seek functions, right? Things like map and filter and all that stuff, like they have a bunch of they're common recipes, right? They know how to walk through a sequence. So they use first and they use next or rest or whatever, and they walk through a sequence from beginning to end. As you get the first element, you do something to it, right? You either modify it in map, you maybe throw it away and filter, or keep it and filter, throw it away and remove, something like that. Or maybe you'll make multiple things that come out of it, right? Like mapcat. So those are kind of the three basic shapes of sequence functions. And then at the end, you put them somewhere. You put them into a new seek that you're building via lazy seek or something like that. So there's really those three parts. There's the reading the seek, doing a thing per element, and making a seek at the end. And so the key insight that Rich came up with is that the first and the third parts are incidental. They're not the important parts. The important part is the middle part. And if you have that, so you basically all you need is the parts that are independent of the sequence, the input or the output sequence are basically give me some initial starting state, which many transducers don't need, but some do. If you're doing something like partition, right? It needs to build up a partition. Or given a new element, do something, or I'm done. In which case so there's basically start, transform, and complete. And so we have a function like that already. It's the reducing function. So the reducing function has a zero arity, which is the monoidal, give me a initial thing.
Whoa, he's doing a double here.
Not a monad, a monoidal.
Yeah.
It's not in the category of endofunctors.
Exactly. So you have the reducing function has the init and it has the transform, but the transform is a little weird there, because it sort of has an implicit accumulator, and then we don't have a completing thing. We don't have like a you're done. That's like also implicit in reduce. So but you can add that. So if you have a function that has a 0, a 1, and a 2 arity that can represent the init, transform, and complete parts, that is a transducer. So that's a transducing, that's a reducing function. Sorry, it's not a transducer. That's a reducing function. A transformer takes a reducing function and returns a reducing function. So, and it does that by basically building stack-like on top of another transducer, or so another function that takes a reducing function or returns a reducing function. So it is a stack of reducing functions defined by transducers.
One too many users.
It's a transforming reducer.
But if a transducer is a stack of transducers, then what's at the bottom
A
of the stack?
transducer is not a stack of, so
Okay, all right.
say I mean, they have the same shape, right? So like if you have one reducing function, if you have one transducer or many transducers in a stack, they have the same input and output, which is a reducing function. So as long as you can seed the initial one, you're fine. You can stack them up.
Okay, so a transducer is a thing that takes a reducing function, does something to it, and returns a reducing function.
And if you have that, you can reduce over that. So, and you don't have to reduce over a sequence. You can reduce over a collection too, right? You can reduce
Directly on you don't have to turn it into a sequence.
abstracting away the
Yeah.
input sequence and the output collection. So,
Yeah.
and the
Okay.
thing you have in the middle is just one giant function. So there is no intermediate collections. There's just one. So like the key insight here is that you can treat any sequence function as you can implement it as a reducing function, and you can combine those reducing functions together into a bigger reducing function without ever making any of the intermediate stuff.
Right. And it's reusable also. So you can,
Because it's a recipe and not a thing tied to an input or an output, you can,
right.
you can pass it around, you can combine it, you can save it for later.
Right. You can add other stuff onto the end of it.
It's just a
Yeah.
function.
Yeah. So I have a question about the design of transducers. Why why is it why does it use a function with two different arities? To me, that is um it's got two problems design wise. One is that uh usually when you have two arities of the same function, they mean like this it's conceptually the same function, but with like a case where you don't have this argument, right? So they do the same thing, the two different arities. And then the other problem is that if you have one, you don't know what it is. It just looks like a function. And you don't know that, oh, this is actually a reducing function that I can pass to one of the transducer functions. So,
I
um,
agree with
yeah.
you that those are both downsides of this approach.
Mhm.
So I'll start with that.
Okay.
And like the alternative approach would be to like make a protocol, right? Or
Right.
something like that. And then you would have a type.
Or a type that just takes two functions or something like that.
Yeah, I mean, you've anything that collects function signatures. So protocol, interface, you know, uh, a family of multi-methods, a map of functions. There's lots of
But
ways
then
we
it
solve
wouldn't.
this in Clojure. A protocol is probably the closest match, I think. And
Mhm.
we could definitely have done that. The big downside is, well, so the two downsides to using a protocol, one is that you then aren't making one function, you're making, three functions or whatever. So that's a downside.
Sure.
You don't have one thing to pass around, you've got a package of things to pass around. So depending
Right.
on your point of view, that's easier or harder. And then the other thing was we actually already had a bunch of functions that were partial matches to this with the reducing function. So there is a completing function in Clojure Core, which you can give it a reducing function, and it will give you back one of these transducer reducing things, and just fill in the completing arity that didn't exist.
What's it called?
It's called complete.
Mhm.
Okay.
It just adds a two arity to the reducing function you have that returns the thing it's passed. So it doesn't do anything extra, which is sort of the default completing.
Ah.
Huh.
So it allowed us.
And so what's an example of a function that you could just pass to that?
any function you would pass
Sorry,
into
I cut out. What is an example of a function? No,
any function you could pass to reduce.
sorry,
So
lag.
conj, for example, we actually patched conj so that
Hmm.
it didn't have that problem. But um, uh, anything that takes an accumulator and a single element, so any kind of append like function is probably a good match already.
Hmm. Got
Uh,
it.
and to make a bit of a side transition into core async and Flow, Rich is actually following the same pattern in Flow with making, so Flow is a new thing that Rich has been designing for core async that is basically how to define a set of concurrent running processes that communicate via core async channels, where each process has at the heart of it a pure function. So you basically define pure functions that say, given an input, here's what I should do for output. You define a flow configuration, which is all the wires between those things, and some ilities about things like, oh, this is a thing that does computation. This is a thing that does IO, and this needs, different little knobs and stuff. And then you can just start the flow and it will start all that up. And so the actual process control under the hood has a protocol, but there is a helper function that you can give it that has certain arities that map into that protocol. So this is a slightly more complicated version of the transducer approach, which we could have implemented it as a protocol and then as some mapping of function into protocol. And I don't know if we
Mm.
ever considered that, but that would have been an interesting choice. The other sort of interesting aspect, going back to transducers, as I'm just thinking about it, is that one problem with protocols in particular is that they're not accessible from Java really, and our implementation just happens to be split half and half between Java and Clojure. So I mean we already have this problem kind of with reducers that they have to sort of cross the divide. And so we have basically a reduced protocol that's defined in Clojure, but that has support for a well-known internal Clojure interface, iReduce, that lets us plug in Java implemented reducers into the protocol that knows how to do reduce. So there's it just makes things more complicated because of all that. If we had
Yeah,
protocol bottom and less of
sure. Well,
Java, then that would be a problem, but that's not where we are. So
yeah, I was actually thinking maybe the opposite of that, which was just make something that implements ifun that so it kind of acts the same as the function, but lets you attach, I don't know, like a class name to it so that you know what you're looking at. Yeah, but maybe I haven't thought it through that much, so
I mean,
maybe
It's
I don't even know what I'm talking about.
not as much. So you have to do something extra to make one beyond making a function. So it's another step.
I'd like to see a talk on this flow thing that you're talking about because I'd like to see a diagram of it working. I think
Yeah, I
that
can. I mean, there's docs out there that it's not. We haven't released it yet. So,
yeah.
but the code is out there in some form, and there are some docs for it. I have those. I might have them up. Yeah, here.
Sort of.
I don't
I've
have.
been
There's no
just trying
diagrams
to.
here. I do have some. I did a talk at the FP Conf a few weeks ago, and there are some diagrams in there.
Oh, I'd like to see it. I have the red string guy from the meme in my head. So thank you, and we can put this as a link in the episode description as well for folks to look at the core.async.flow doc that Alex just put in the Zoom chat for us. So save that for later. do you have anything to plug or anything that you're excited about that you want our viewers to know about, look at, go to?
Flow. So that's one thing. Uh, More coming soon. So we'll hope to. We have a bunch of in-flight work on Core Async, and so the plan is to release that soon. And then after that, we plan to do an alpha of Core Async with Flow in it. So that's hopefully that's in the next week or two horizon.
Oh, wow. It's coming soon.
Yeah, it's basically there. We're just doing various things on it. So it's trying to improve docs and different things. But and then the other thing I would say is the Clojure Brain Teasers is my new book that I wrote with Jordan Miller, and that is out in ebook and on its way to printing, and so should be in stores soon in physical form. So
Yay, congratulations. That's awesome. I've read it. It's really good. It's fun.
I appreciate your feedback.
Exciting.
It's helpful.
Clojure Brain Teasers. And we will have a link. It's published by Pragmatic. The Pragmatic Bookshelf looks like has it.
Yep, you can get
Pragmatic
it now in
Programmers.
form, and that is the final book is available in ebook form. So you're getting the same thing that will be in the physical book at the end at this point. And I'm working on a 4th edition of Programming Clojure slowly, so which will be sort of refreshed and just include all the 112 stuff, but also we'll have some new chapters. Still figuring out exactly what those will be, but there will definitely be some more on Clojure CLI and Dapseden and tools build and maybe some Babashka related stuff. Maybe.
Only if
People are
a
using
certain percentage of Clojure programmers are.
We'll see. So
All right. Thank you. We will have a link to we've got links, a link to Clojure Brain Teasers. Is there who would you like to see us invite? Who would you like to see in the hot seat?
I think it would be cool to hear from Raf, who works with the Clojure Camp stuff. I don't know if you've interviewed him for Deafin before or whatever. I would.
No, it would be really good. Yeah.
Yeah, I think he's doing some awesome work over there. So
Yeah, we need to get Clojure Camp more front and center, that's for sure. Yeah.
yeah.
Oh wow. This is so cool. I did not know about this. This is you get buried in just whatever you're working on for your job.
Yeah.
Oh, this is great. We'll put a link to clojure.camp in the episode notes as well.
It is a active, thriving little community over there. So I appreciate it. I watch don't really pay attention to it very closely, but I do stop by their Discord occasionally and just see what they're up to. And he's really built a good group over there.
Hey, Alex, can I ask you, what is your favorite brain teaser?
Favorite brain teaser. One that I don't know if I have a favorite brain teaser, but one that I spent a lot of time making things, messing with to make it was what did I call it's the one that's called I think it's Boom Goes the Dynamite or whatever is that one.
Boom Goes the Dynamite.
Yeah. Boom Goes the Dynamite. Yeah, so that one's it's all about how concat can be a latent recursion bomb for you. Sandra Sierra wrote a great blog post about this a million years ago, which I still think is the canonical canonical description of it. But I had a good time drawing the images for that one. Trying to figure out a good way to explain it. I'm still not happy that I really got there, but I got better with editor and reader feedback over the version. So
Yeah, that's just super challenging. how to describe that stuff.
It's recursion, so it's one of those things.
I don't know. It's maybe I'm more solid on transducers than I was before that explanation, which I have not felt about the other explanations. So
Well, I'm
I
glad I
am
helped
sure
at
that
least.
it's always it's yeah that so maybe the explanation for boom goes the dynamite will also be very good. And is there so these closure brain teasers, people are making their own solutions to things? Is there like a forum where people are comparing them? Is there a place where you are going to read everyone's solutions and see what things they're doing that you hate? And
So the format of the book is basically you get a short snippet of Clojure and you say, what do you think the answer is? And then you turn the page, right? So before you turn the page, you can either just think about it in your head, in your hammock, or you can go to a REPL and type it and see something and say, that's not what I expected. Or, you could, talk about it with friends or whatever. And so choose what you want to do before you turn the page, and then turn the page and you'll see what actually happens and hopefully some useful understanding of why that happens. So.
that's very cool. That's wonderful.
And it was
Do
really intended to not be gotchas, things that are like bugs or just gotchas, but the intent was always to highlight places where maybe your mental model is not the same as the mental model of the core team or something like that. Like, so where they're hopefully to illuminate the choices that leads that to be the expected output. But
all right, revealing the deeper truths. Do you have a hammock? Do you have a physical hammock?
I do not.
You
Oh
don't?
no.
Oh
How do you
no!
even
What do you
program?
think?
Well, as Rich has said, the point of that talk was not the hammock. So
Does he
Okay, I have
have
to
a
rewatch it because that's what I thought the point of the
does he
talk
have a
was.
hammock?
no, the point of the hammock is the point of the talk is that you gotta step away from your problem. So
Yeah, but is there like I does he have a hammock?
he has a hammock.
What kind of hammock is it?
I don't have
It's
that.
important. I need to know what kind of pen you write with.
I want to know if it's like one of those portable hammocks where like I gotta go into the hammock and he like pulls the little hammock out of his bag and like unrolls it.
He
We got
seems
to
like
have him on
most
and
likely
ask him.
yeah, most
The
likely.
kids are into hammocking these days. Uh,
There's a lot of
they
hammocking
carry
out on the college
yeah
campuses these days.
yeah
I have three
yeah.
kids in college, so I occasionally am around, campuses, and there's often
They're hammocking. It's not a euphemism. They've got the hammocks.
Where do you do your thinking? You're taking a step away and
I walk the dog.
Mhm.
Bogus is also a big fan of walk the dog. So we both enjoy that. I often,
You've got a big dog, haven't you?
I do have a big dog. I've got a Great Dane.
A
So
Do
Great
we
Dane.
is the Great Dane in the room with us now?
Needs a lot of walking, I
no,
guess.
no, he doesn't hang out with me. Not long. He hangs out with me at night. So
Oh,
he's a good bud.
Nice, good boy. Yeah.
all right.
If I
Well,
unblurred, I've got a picture of him behind me.
it's you're blurred. So, oh yes. So
I don't know for how to unblur. There's
we
Oh,
are.
look at him.
Oh, wait, why do you blur this? There's nothing
It's nice in the back. Yeah.
yeah. Yeah.
We can focus on Alex though when it's blurred. We just look at the
I know
dog
we'd just be
otherwise.
I was
looking
just
at
looking
the
at the dog
dog.
like, oh, did you see the dog?
What's he saying? I don't know. I love
What's the
that
dog?
dog. What's he saying?
the other
Listen,
guy behind
We'd never have got enlightenment through transducers, Mia, if that dog was there. You'd just be looking at the dog all the time.
on
I've
the
got a
top there
lot
is
of
my dog
pictures.
Jake, and then the bottom is my uncle Al, who's Al Miller, who was has passed away now, but he was a very inspirational figure in my life. He had a polycystic kidney disease, and people told him when he was 16 that he was going to die, and he had 3 kidney transplants, lived into his 60s, and Was an amazing guy. Did a lot of cool stuff.
Is that
Wow.
has he got a what's on the tripod there with him?
It's a camera. He was a photographer, a wildlife photographer for a while.
Oh wow.
Did a lot of work with conservation in Portland. So there's a lot of things in Portland that exist only because he and a few crazy college friends of his were there fighting for it. So
That's
That's
wonderful.
cool. Yeah.
Yeah. Great guy to have on your wall.
mm.
All right. We've hit the hour. We actually started on time. So
Wow.
oh, we do have
First time in years.
Slackwise on chat wants to know, since we've all left the steaming wreckage of what used to be Twitter, where can they find you? Where is everyone now?
I have drastically reduced my social media consumption and involvement, but I am actively on all of the Clojure channels. So um, Clojure and Slack is probably the place where I talk to people the most. I do have a Blue Sky account, but
Do you? I tried to find it to tag you and I couldn't.
yeah, I think it's just my name. I don't think it's anything complicated, but
Oh, that's why I was looking for Pure Danger.
yeah, I didn't use Pure Danger on that one.
It's not taken.
AlexMiller.bsky or whatever. So Alex Miller word. So,
Yeah.
but
Getting less dangerous as you get
I
older,
don't
Alex.
have it on
Yeah.
my phone and I don't actively open it. So that's not that
Impure
hard.
danger.
It's I got off all
I remember I had I forget, someone I worked with once said usernames are like tattoos. You you get them when you're young and then you have them forever. And so this is not Alex Miller DB. Alex Miller DB.bsky.social is not you.
no.
Hey. Oh,
Well,
here we go. You're Alex Miller.bsky.social. There you are.
we
All
should
right.
probably close out. We're kind of
Yeah.
got
Is Rich on anything where people can
oh
follow him?
No.
Okay.
That is the last thing he wants.
He's in the hammock.
I will say, because
Yeah.
I heard from people this was not obvious from my conch talk, but Rich is still very actively working on Clojure, and I talk to him every week, and sometimes every day, sometimes every hour during some of those days. It's really hot on something, so he's still actively working on it.
that's cool.
That's really good. Yeah.
Thank you so much for joining
Yeah,
us.
thanks for being here.
My pleasure. Thanks to you guys for doing this. I think it's a nice forum, so I like watching it.
We might have to retire the transducer option now. I don't
No,
know.
no, I want more diagrams. I want more whiteboards. I want the
I want
hand
more
waving.
satirical answers is what I want.
I want the hand waving. I love to
Or like a live demo. I'm
I
gonna
love
make
to
you a
watch him
transducer
squirm.
right now.
I
I
love
think
to
the
watch
next
him
guest
squirm.
has to do the stateful talk, not just the generic talk.
Oh,
Oh.
stateful
Should have pushed
transducer.
Alex on that one, really, but that's next time. Yeah.
Can I ask another question?
Oh, oh.
I know it's like a final hour and you can answer as satirically as you would like. Why is volatile not the default in Java?
Oh.
Why?
Probably because it's slower.
So they made the single-threaded version the default.
Yep. I mean, originally the collections were not synchronized at all. So
Right.
when I started Java, there was no hash map or array list or whatever.
Yeah, wow. What did people do back then? All right.
A bug was a physical creature crawling around on your punch cards.
Don't put me there. I'm not that old.
Debugging was a can of Raid.
All right.
All right. Thanks, Alex.
Yep.
Yeah.
Everyone out there watching, please subscribe to the channel on YouTube. That way you'll know when we've got a new episode coming up. And also, you can find us on the Clojurian Slack. There's a channel just for
I'm
apropos.
not on it.
You're not on it.
I
Wow.
gotta get on that.
You get on it. Yeah.
I gotta get on that.
And
You're definitely
yeah.
invited, Mia.
I think that's everything. Anything I'm missing now that we've changed everything around?
I don't think so. We are every other Tuesday and we are
Every other
serious
Tuesday.
about it. So, if you oh, I am on it, Apropos Closure Cast. It's called Apropos Closure Cast.
Every other
You know.
Tuesday. Thanks for listening live. If you were there were about 22 people I saw at the peak, which is pretty good. And tell your friends so we can have more. All right. See you later, everybody. Bye.